This video will cover section 2 of your Unit 7 Similarity flipbook. This is the bottom flap of section 2. It is titled Prove Similarity. And the essential question is, how can I prove that two shapes are similar? Meaning, they're the same shape, but different size. Before we do that, I want to go back to the previous video a second and add some. So look right above this flap where you did the properties of a dilation. Will you add these two definitions to the bottom of that page? And I want you to add corresponding. Corresponding means the same position. So if I had two triangles that were drawn like this, and I told you these two triangles were similar, if I told you that this side right here was the same side of the triangle as this side, those two sides correspond. Same thing with angles. If I told you this angle matched up with this angle, those are corresponding angles. And then the next thing is, I've talked about prime notation. That's a way of mapping or matching up corresponding vertices, and it's also a way of identifying what's the pre-image and what's the image. Pre-images will typically have letters like A, B, C. Image, we can use then prime notation to write them like this, so we know which vertices of the image match up with the vertices of the pre-image. You can pause the video and get that written out, and then go ahead and continue. Alright, let's continue on with how can I prove that two shapes are similar? There are three different methods we're going to go through to do this. Here is the first one. If segments drawn from the corresponding vertices of each shape intersect at exactly one point, which is the center of dilation, then the shapes are similar. So you take a moment, class. Please use a straight edge, side of a piece of paper, a ruler, anything with a straight edge, and carefully draw these line segments. You can see if you do it carefully, you're going to end up with a point on your page, and I actually have the point already drawn in for you. All you got to do is connect those vertices together. Notice these are corresponding vertices of two similar shapes, and let's just label this as the center. Again, it's called the center of dilation. If two shapes actually have a center of dilation, meaning all these lines match up with one point, that means you can prove that those two shapes are similar. There's the first method. Next method. If, I'm going to move this over a little bit, if the corresponding sides are proportional and the corresponding angles are congruent, then the shapes are similar. We covered that under dilation properties. If you've got a dilation, that means you have similar shapes. And in a dilation, corresponding sides are proportional and corresponding angles are congruent. So let's take a look at these two shapes. How about if I label these? Let's just pretend that this one is our pre-image. So I'm going to label that as A, B, and C. And let's just say then that this is our image or our copy. This is actually reduction then. Notice that we got smaller from our pre-image to our image. And I'm going to label that A prime, B prime, C prime. So here's what this is telling us. If you can prove that, angle A is congruent to angle A prime, and angle B is congruent to angle B prime, and angle C is congruent to angle C prime. You can prove that all those corresponding angles are congruent, and you can also prove that corresponding sides are proportional. Therefore, the ratio of AB to A prime B prime is equal to the ratio of BC to B prime C prime, and the ratio of CA to C prime A prime, if all of those ratios are the same, then you've just proven the sides are proportional. That means they've all grown or shrunk by the exact same scale factor. If you can prove all the angles, corresponding angles are congruent, and all of the corresponding sides are proportional, then you can say that triangle ABC must be similar to triangle A prime, B prime, C prime. So you can prove similarity by proving all the corresponding angles are congruent and all the corresponding sides are proportional. There's the second method, definitely a longer task than the first way. And then we have one more way. If you can use transformations to map, that means to move or to copy one shape onto the other, then the shapes are similar. So let's take a look at this. We've already gone over transformation notation in a previous video. Let's pretend that this shape here, let's call this shape A. Let me change color here. Let's call this shape A, and we're going to call this shape A prime, prime, prime. The reason why is, you'll see in a moment why we're calling it that. Okay? Now, if I want to prove that this shape A is similar to A prime, 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 if I can find a number of transformations that will get me from A to A prime, 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 then I can prove that those two shapes are similar. Let's take a look. This is a little bit complicated, but we'll go through this process. Let's take a look at the original. This is our original image, or pre-image A. Let's go ahead and write down the coordinates. So let's say this is at 1, 3, and this coordinate is 1, 1, and this coordinate is 3, 1. So there's our original coordinates. Okay, now to map shape A onto shape A prime, 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 we can use reflection, dilation, translation, and rotation to get from this one to this one. Now I'm going to give you guys a little tip here. The way I do it is, I'm going to do this, I will always do this in a certain order. The best order to try to get from the original pre-image to the image is, I would always try rotation first. Next I would try reflection. Next I would do dilation. And the last thing I would always do is translation. This makes it a lot easier for me to get from one shape to the other. Now, sometimes you don't need rotation. Sometimes you don't need reflection or dilation. In this case, I can tell you right now, there is no rotation here. There definitely is a reflection, and there definitely is a dilation, and it looks like there's probably a translation as well. Let's go through these. To map shape A onto shape A triple prime, I figured out the first thing I wanted to do was reflect. And I want to reflect the shape A across the y-axis. So I'm going to do that right now. In my notes here, I wrote the word reflect, and I wrote the transformation notation to reflect across the y-axis. And that means that our original point, let's change this to a different color. Our original point is going to change to our new point. So our original point, let's try the first one, was 1, 3. That's going to change to -1, 3 based on this transformation. And I've got 1, 1. That's going to change to -1, 1. And I've got 3, 1, and that's going to change to -3, 1. So let's go ahead and do that. I'll plot those points. Here's my first one, -1, 3, -1, 1, and -1, 2, 3. Sorry, let's see. Was that 3, 1? 1, 2, 3, 4. Oh, I just noticed something. Let's correct this. This was supposed to be 4, comma 1. Let's change that color. This should be 4, comma 1. And that means this needs to be 4, comma 1. It's going to change to negative 4, comma 1. Let's do that. So this is going to be 4, comma 1. Negative 4, comma 1. There is our new point. 1, 2, 3, 4. I had it in the right place. So there is our first copy. Let's call that A prime. Okay, there's our first copy. It's a reflection across the y-axis. Now the next thing I noticed was, well, this shape is much bigger than the original. The image is bigger than the pre-image, so I'm going to have to go through a dilation. And when I check this out, class, I could see that, well, this up and down, this vertical side is 2 units large. This vertical side is 1, 2, 3, 4. It's twice as big. That means my dilation is going to be 2 times as big. The image is going to be 2 times as big as the original. And our original now is A prime. So now let's do the next one. So my points are now going to change. Look, I'm going to take the negative 1, 3. I'm going to take that from this new copy now, and I'm going to translate that, or transform that. 2 times negative 1 is negative 2. 3 times 2 is 6. There's our first new point. We're going to take our new point, negative 1, 1, and we're going to multiply that times 2. That's going to be negative 2, 2. And we're going to take our negative 4, 1. We're going to run it through our transformation, and we're going to get negative 8, comma 2. So there are our new points with our dilation. Let's go ahead and map those. I've got negative 2, 1, 2, 3, 4, 5, 6. Negative 2, 2. That's actually right here. Kind of messes us up. It's right kind of inside our triangle. And then 1, 2, 3, 4, 5, 6, 7, 8. 2 is right there. So now we have a new triangle. I'll just go ahead and make that in red as well, the best I can. You should be using a ruler for this. Ugh, it's terrible. So there's our next triangle. Let's call that A prime prime. So there's our second copy. We've reflected our original pre-image across the y-axis. We've now dilated it, so now it's as big as our final image is. Now look how easy it is, class. Now we're going to translate. All we got to do is move this A double prime to A triple prime. Let's pick one point on A double prime. We go 1 unit to the right, and 1, 2, 3, 4, 5, 6 units down. So our translation is plus 1 for the x value. So the x value, we add 1, and we subtract 6 from the y value. There's our translation. Let's go ahead and run through that translation. I'll put that in dark blue. So now we're going to take our points from A double prime, which is now negative 6, 2. Let's run it through our transformation. We're going to add 1 to the negative 2. That's negative 1. 6 minus 6 is 0. There's our first point. Let's take negative 2, 2. Run it through our transformation. Negative 2 plus 1 is negative 1. 2 minus 6 is negative 4. And we've got negative 8, comma 2 is now going to be negative 8 plus 1 is negative 7, and 2 minus 6 is negative 4. And there are our new points. Let's go ahead and check our points now. Negative 1, 0, that's exactly where we want to be. Negative 1, negative 4, it's exactly where we want to be. And negative 7, negative 4 is right here. It's exactly where we want to be. These 3 transformations will get us from our original shape A to our copy A triple prime. And because we can use these different transformations to get from shape A to shape A triple prime, therefore we have proved that these 2 triangles are similar to each other.